Okay, now we are looking at question number 3. We are looking at B part. So if you haven't read the question, please pause the video and read it. The idea of the questions are again and again fundamentally same. There is not much of a difference. Okay, so if you look deeply, it's the same idea repeated, and in this case they are giving you the power, which is 1.5 kilowatts. So the places where you would make mistake is converting from forgetting to convert the kilo, so keep it converted. Then the heat capacity of air is given. So okay, so this is a tricky part. I will explain to you why it's tricky, but right now you just keep it so. The heat capacity of the air is given, that is 720 joules per kilogram per degree Celsius. They are asking you to calculate the time taken to increase the temperature delta T from 15 minus 8, that is 7 degrees Celsius, and the mass of the air in the room is given as 65 kilograms. So it's just the same ideas again and again. Earlier it was a water in a kettle, now it's an air, and next time it might be something else, but it's the same fundamental idea which is being repeated again and again. So if you want to calculate the time taken by the heater, now time, there are only two equations so far we've been dealing in these kinds of questions, right? One is the E is equal to mc delta T. The other is the power is equal to energy divided by time. So time comes only in this equation. That must hint you that you have to use like this equation definitely. That means that using I look at this equation. So this is how the brain works. I hear the word time and I understand that so far we've been using these two equations in these kinds of questions. So power is equal to energy over time. So if I am supposed to use this equation, because that's the only equation out of these two which has time, then I should be given the, like, I see what are the quantities from this equation that are given. So I see power is given, time is given. So I understand that from this equation, sorry, time is not given, power is given, time is asked. So if I am to calculate the time using this equation, it will be time is equal to energy over power. So if I am supposed to use this equation to calculate the time, then I should know the energy and power. Power is given, so I need to calculate the energy. So now I understand that I have to calculate the energy. Now you can go back and I try to use this equation to, I'm trying to see whether I can use this equation, the only remaining equation, to calculate the energy. It must be possible, otherwise you can't do the question. Mass, yes, given. Specific heat capacity, well, sorry guys, this is not heat capacity, see, this is specific heat capacity, this is joules per kilogram per Celsius. Sorry, that's not heat capacity. In the question paper also it says specific heat capacity. That was a mistake. So C is given, fine. Delta theta is given, delta T is given, fine. So all are fine, just use the equation. So 65 times 720 Just be careful whether you are consistent with the units. Yeah, kilogram, here also kilogram, fine. Then 7, this gives you that energy is equal to 3.3 times 10 to the power 5 joules. Okay, once you have got the energy, see 3 point, okay, what is this value? 65 times 720 times 7, that is, yeah, 1 2 3 4, 1 2 3 4 5, yeah, it's 1 2 3 4 5, it's 3.3 into 10 to the power 5 joules. Then to calculate the power is equal to, so not power, to calculate the time, so time is equal to energy over power. Energy is 3.3 times 10 to the power 5 divided by the power, 1.5 times 10 to the power 3. So that gives you 3.3 times 10 to the power 5 divided by 1.5 times 10 to the power 3. That gives you 220 seconds. Okay, so there's only just one issue here, that is in the mark scheme. In the mark scheme here, yeah, so if you look here, so if you look here, it shows 10 to the power 5, but if you look here, it shows 10 to the power 6, 3.3 into 10 to the power 5 here, and 3.3 into 10 to the power 6 here. So this must be some printing mistake while converting to PDF or something. Okay, so don't be worried about that. Now the next part of the question is the next part of the question state 2 reasons why the time calculated in BI is smaller than the actual time to raise the temperature of the air in the room from 18 to 15 degrees. So they are saying why the time calculated is smaller than the actual time. That means the actual time is more than this time, because obviously there's going to be heat leaking from the room through different parts. It's going to transfer through the walls, going to go through the windows, and that's there. So the heat energy will be transferred to the outside environment through the walls, through the windows, through the furnitures, etc. That's one thing. The second thing is, not only it will simply pass through, when it passes through, it will heat up the walls, the ceilings, the windows, and everything, right? So on one hand, it will pass to the outside environment, outside the room. On the other hand, it will heat up other things in the room, not just the air. So the heat energy will not be used for heating up only the air. It will heat up whosoever, whatsoever it is. It's really warm. Like, it welcomes all the things in the room. The furniture and you all are included. It will heat up everything. So we just calculated assuming that it is totally empty, purely empty room, which is kind of a poetic, artistic visual, but in reality there's going to be furniture, there are going to be people, so it's going to be used to heat up all those things. Okay. On the other hand, there might be outside air entering, there can be draughts, that means wind movement. So the wind might not remain, it might not be the same amount of air, or when a cool air comes in, again you have to heat it from lower temperature, so that would take more energy, and more energy means more power into more energy means power. Since power is kept constant, you need to give more time for the heater to produce more energy.